Hello everyone, welcome back to Deeksha Karnataka YouTube channel. In the top 30 questions, today I am going to discuss the chapter Alternating Current. It's a very highly important chapter. 4 questions comes from this chapter, so you cannot ignore this chapter. This is a relatively easy chapter and a lot of questions are coming very easy. We will see some of the previous year questions, some of the questions which might come in your year. So let's see the questions. In series LCR circuit, obviously due to time constraints I am not able to update all the years in this PPT, but some of them are previous year questions, some of them are not previous year questions, so that is why it is a top 30 PYQ, top 30 questions, PYQs plus important questions. Okay, in series LCR circuit, at resonance the phase difference between voltage and current. So in a resonance circuit, the current and voltage both are at the same phase, because so the phase difference will be 0. Same phase means phase difference is 0, right? So definitely option D is correct in this case. Now next question, an ideal transformer has a turn ratio of 10 when the primary is connected to 220 volt 50 hertz AC source. The power output is, so turns ratio, maybe you are confused what is turn ratio, what is about primary connected to this. So turn ratio, don't worry about this question. Turn ratio is number of turns in primary divided by number of turns in secondary is called turn ratio, but that is not important. The question is ideal transformer and they are talking about power output. So power output should be equal to power input, does not matter whatever is the turn ratio. Ideal transformer power is conserved, so energy is conserved, whatever is the input power, same amount you will get as an output power. Now next question, the relationship between peak value Vm of voltage and RMS value Vrms is. So what is the relationship? We know that Vrms is equals to peak value divided by root 2. Okay, so Vrms equals to peak value divided by root 2. So peak value is basically root 2 into Vrms. Okay, so this is the correct relationship. So correct answer is option D in this case. Next question. Obviously, if you are preparing for your KCET 2025 exam, then definitely you must have Abhyas KCET test series. It is a must have. There is no option if you want to prepare for your KCET exam. Okay, and if you are watching this video, then definitely you want to practice more such questions on your own with some guidance from us. So that is why Abhyas KCET test series is providing you both the options. You can take the test 60 questions in 60 minutes, and once you are done with the test, if you want all the explanation, all the questions, then definitely we are there. We will be helping you to understand all the important questions, all the important solution to the questions, right? So that is why Abhyas KCET test series is providing you the perfect platform for practicing important questions, understanding the concept. So you will get all the one-shot videos there and 5-year insight of previous year KCET papers, how it was. So definitely it is only priced at 1498. So don't wait. Already hundreds of students are attempting it, and if you have not yet started then your journey, then definitely you should consider and attempt it right now. The link for this is given in the description. Go to the website, register yourself, and if you want to try the free trial, you can try the free trial. If you want to purchase it, 1498, that is also available. Let's start with the next question. An alternating current is given by I equals to I1 sin omega t plus I2 cos omega t. The RMS current is given by. So RMS current is basically based on whatever is the resultant current, right? Now let's see how can we do that. First, what we will do, what is the current? Current is given I equals to I1 sin omega t plus I2 cos omega t. Okay, now let us substitute I1 is equal to A cos alpha and I2 equals to A sin alpha. This is just a substitution, common substitution, right? We will put it over here. So what you will get, you have done this kind of substitution in your mathematics, right? If I am not wrong. Now put that value over here. So A cos alpha sin omega t plus A sin alpha cos omega t. Okay, so what is this formula? A will be common, you will get sin A plus B, that is omega t plus alpha. Okay, now what is the value of A? So we have combined these two into a single form. What is the value of A? From here we can say that A is nothing but square root of I1 square plus I2 square. Right, this is the value of A, right? This is how we do the substitution. Alpha is tan inverse I2 by I1. Alpha is not, we are not interested in alpha. Alpha is the phase, but we see that this is basically the function that we are familiar with. So this is basically Im. This is the Im sin omega t plus alpha. So this is the peak value of the current. So what is the RMS current? RMS current is peak value of the current divided by root 2, which is nothing but I1 square. So it will basically I1 square plus I2 square divided by 2 whole square root. Okay, so definitely correct answer is option A. Next question. A series resonance AC circuit contains a capacitor of 10 to the power of minus 6 farad and an inductor of 10 to the power of minus 4 Henry. The frequency of the electrical oscillations will be. So when does it resonate? Resonance happens when, we know that resonance happens when it is XL equals to XC. Okay, or 2 pi f L equals to 1 by 2 pi f C. Okay, so we are familiar with this. So from there we can calculate f equals to 1 by 2 pi f square root of L into C. Right, in case you forgot the formula, this is the formula. If you remember it, obviously you can use it at one shot. So f is equals to 1 by 2 pi square root of L was given 10 to the power of minus 4 and C is given 10 to the power of minus 6. So multiply them, minus 4 minus 6 is minus 10. So square root of 10 to the power of minus 10 is what? 10 to the power of minus 5. But entire thing is in division. So once you do this 1 by, what you will get? You will get 10 to the power of 5. So basically this entire thing is 10 to the power of 5 divided by 2 pi. Okay, so the answer is 10 to the power of 5 divided by 2 pi. Option A is correct. Right. Next question. In series LCR circuit, R is 300 ohm, L is 0.9 Henry, C is 2.0 microfarad and omega is 1000 radian per second. Then the impedance of the circuit. Easy question. Impedance. What is the formula? First of all, impedance formula is Z equals to square root of R square plus XL minus XC whole square. Right? This is the formula. Now we will find XL. First stage, calculate XL. XL is omega into L. Omega is 1000. So see, in case of PU board, when you are solving this kind of questions, you have always 50 hertz, 50 hertz, 50 hertz was coming so many times. The calculation part was boring for this chapter. Now when you come across the KCET part, similar questions you will get, but the thing is, the good thing is the values are given such that it is easier to solve. Okay, they will not give you problem which is very difficult in calculation front that you cannot solve using a calculator. Okay, remember that. So XC equals to 1 by omega C. So 1 by 1000 into C is 2 microfarad. Micro means 10 to the power of minus 6. Okay, minus 6 into 1000 is 10 to the power of minus 3. So it will be 1 by 2 into 10 to the power of minus 3. Now this 10 to the power of minus 3 will go up. So it will be 10 to the power of 3 divided by 2, that is 1000, divided by 2, that is 500 ohm. Okay, so 500 ohm is the XC. Now put the values over here and calculate the impedance Z quickly. So Z equals to square root of 300 whole square plus 900 minus 500 whole square. So 900 minus 500 is what? 400. So it is 300 whole square plus 400 whole square. Now can you tell me the answer in one line? Yes, it is 500. Why? If you remember a small part, that square root of 3 square plus 4 square is equals to 5. If you have solved enough problems in your class 10th Pythagoras theorem, then you are familiar with this term. Okay, almost every one other problem you are coming across this formula, right? 3 square is 9, 4 square is 16, together they are 25, square root of them is 5. Similarly, 300 square and 400 square will be 500, normal 500. So answer is normal 500. Option A is the correct answer. Next question. What will be the reading in the voltmeter and the ammeter of the circuit shown? So here we have a circuit, here we have a capacitor, here we have an inductor, here we have a resistance, some voltage is applied of 90 volt. Okay, ammeter is over here and voltmeter is across connected something like this. Here we have a resistance and XC and XL are 4 ohm and 4 ohm. Okay, so XC and XL, so try to understand this. XC and XL are given, L and C are not given. So basically that means both of them are equal. That means the circuit is in resonance condition. So circuit is in resonance condition means you can consider the entire circuit. How you can consider this circuit to be? You can consider, redraw this circuit. Basically for resonance, we know that they are basically connected like these two cancel each other. So basically it is like a simple conductor. Okay, and we have connected voltmeter like this. So they have zero resistance. This part has zero resistance. Zero resistance means V must be equals to 0. Okay, we have an ammeter connected over here and a resistance, and we have a 90 volt. Okay, and resistance is 45. So what is the current? Current in the circuit is 90 divided by 45, that is 2 ampere. So because circuit is in resonance, okay, the capacitor and inductor mutually cancel each other and they behave like a simple conductor. Okay, so they cancel each other and it becomes simple conductor. So V is 0 and current is 2 ampere. So correct answer is option B. Next question. A series LCR circuit contains inductance 5 millihenry, capacitance 2 microfarad and resistance 10 ohm. If a frequency AC source is varied, what is the frequency at which the maximum power is dissipated? Okay, inductance is 5 millihenry, capacitance is 2 microfarad and resistance is 10 ohm. Frequency of the AC is varied. What is the frequency at which the maximum power is dissipated? That means they are asking you to calculate the resonance frequency. They are asking you to calculate the resonance frequency. At resonance frequency, maximum power is delivered, and we have already found how to calculate the resonance frequency, right? So I am not going into that derivation again. So in case you forgot, if you remember, very good. If you don't remember, this is the formula. The same question, but the language is different. Okay, only thing is the language is different. So language can be a barrier for you, but other than that it is the same question. Millihenry means -3 and capacitance microfarad means 10 to the power of -6. Now let's solve this part first. So what is the part? We have 5 to the 10. 10 into 10 to the power of -3, 10 to the power of -6. So basically 1 -3 -6. So that means it will be 10 to the power of -8. 10 to the power of -8. 8, and square root means it will be 10 to the power of minus 4, right? Square root means half of the power. Now entire thing is in division. Entire thing is in division. That means it will be 10 to the power of plus 4. Okay, now this thing you have to solve quickly. Okay, this part that I am explaining you right now, this part if you can solve it quickly, you can answer it quickly as well. Okay, now this is not done yet. If you see that all the options has a division in pi, so what I will do, I will take one of the 10 separate, I will keep the 10 to the power of 3 over here, and then 2 pi, then this will cancel, we will get 5 by pi into 10 to the power of 3. So 5 by pi into 10 to the power of 3. So after you solve your question, you have to look into the options once more. Okay, in some questions you look into the options before you answer the question. In some questions you solve the question and then you look into the answer, and then based on that you adjust your solution. Very, very important. Next question. A step down transformer has 50 turns in its secondary and 1000 turns on the primary winding. If a transformer is connected to 220 volt 1 ampere AC source, what is the output current of the transformer? So first of all, we have to find what is the output voltage of the transformer. How to find the output voltage? Output voltage is nothing but number of turns in the secondary divided by number of turns in the primary into V input. Okay, so number of turns in secondary is 50, number of turns in the primary is 1000, and input voltage is 220 volt. Okay, so you just need to calculate it. Okay, 22 into 5 is 110 divided by 10. So the output voltage is 11 volt. So output voltage is 11 volt. Now power in an ideal transformer remains constant. So input voltage is 220 volt, current is 1 ampere, output voltage is 11 volt, current is I ampere. So I will be equals to 220 divided by 11, that is 20 ampere. So you get a very high current but very less voltage, right? Next question. In the given circuit, the resonant frequency is. So here we have, if you see, obviously one thing the circuit is missing is should be a AC source, 0.5 millihenry and 20 microfarad. Okay, we have to find the resonance frequency of this circuit. Direct straightforward question, and we will solve it straightforward as well. 1 by 2 pi square root of L into C. So you will put the value 1 by 2 pi. L is 0.5 millihenry. 0.5 millihenry means 0.5 into 10 to the power of minus 3. And this is 20 microfarad. C is 20 microfarad minus 6. Again, same process. Okay, you will get 0.5 into 20 is 10. So 1 by 2 pi. 0.5 into 20 is 10 into 10 to the power of minus 3 into 10 to the power of minus 6. So it will be what? It will be 1 by 2 pi 10 to the power of minus 8, same problem, 10 to the power of minus 4. So it will go up and it will become 10 to the power of 4 divided by 2 pi. Only thing is here we have to calculate the value. So 10 to the power of 4 means 1, 2, 3, 4 divided by 2 pi. So 2 will be cancelled, you will get 5000. So 5000 divided by pi. So 5000 divided by 3.14. Now how to solve it? You assume the number to be exactly equals to 3. You don't worry too much. Okay, you assume the number to be 3 and then try to cancel it, whatever value you will get. Okay, so 3 divided by 5000. 3 ones are 3. We have 20. 20 means 3 6 are 18. Okay, 18, another 20 is 3 6 18, another 20 6 6 18. Then we have dot dot dot. Okay, so it will be 1666, but as we have solved it, we have reduced this value in the denominator. That means we have got some answer which is slightly bigger than whatever we are expecting. So the answer should be somewhat around between 1500 to 1600 range. Okay, so the correct answer is 1592 Hertz. Okay, just slightly less than 1600 and more than 1500. So this fits our bill perfectly. It was somewhat in the 1500 range. 1500 range means it will be 1592 Hertz. Okay, now next question. In the given circuit, the peak voltages across C, L and R are 30 volt, 110 volt and 60 volt respectively. The RMS value of the applied voltage is. Okay, so what is the given value here? As you can see, here we have C is 30 volt, L is 110 volt and VR is 60 volt. Now to find the RMS value of the input voltage, what we have to find? First we have to find the input voltage itself, maximum value of the input voltage. So how to do that? We can do that by using the formula VR square plus VL minus VC whole square, same as impedance, right? Basically it is we are multiplying with current. Now it is 60 square plus VL is 110 square, 110 minus 30 square, 60 square plus 80 square. Okay, now you can take 10 square common and you can take it outside the square. Not only that, basically what you can do, 10 square, and also you can take 2 square as common. So inside it will be 3 square plus 4 square. Right, so what we have done, 60 is basically 3 into 2 into 10. Right, now square, what we have done, 2 into 10 whole square we have taken outside and 3 square is out inside. This is a simple process. If you know basic mathematics, this part should not take much time. So 10 into 2, that is 20, will come out of the square root, 10 into 2, and inside we get 3 square plus 4 square. What is 3 square plus 4 square? 3 square plus 4 square is 5, so it will be 100 volt. Now 100 volt is the maximum value of the input voltage. So what is the RMS voltage? So RMS voltage is basically 100 divided by root 2. Okay, 100 divided by root 2, that is 100 divided by 1.41. Sir, again we have to calculate? No. So if you look into the option, this is 100 divided by a number, that means it must be less than that number. So it can be only one value, that is 70.7. So I am not even calculating. You can try and calculate it. It will be 70.7. Okay, it will be less than the maximum value of the voltage. So it will be 70.7 volt. Next question. The frequency of an alternating current is 50 Hertz. What is the minimum time taken by current to reach its peak value from RMS value? Okay, very interesting question. Okay, so here we have, generally we say that what is the time taken by it to reach from 0 to peak value. 0 to peak value is T by 4. Okay, so if you know the frequency, you can find the time period and you can calculate it, right? Anyway, so here for that what we have to do, we have to assume that V is equal to Vm sine omega t, that is the normal equation, right? Or it will be equals to Vm sine omega is 2 pi f t, right? Frequency is given 50 Hertz, so Vm equals to sine 100 pi into t. So if you put 50, then you will get 100 pi. Now initially at initial moment, the value of V was equals to Vrms. What is Vrms? Vrms is Vm by root 2. So this is the initial value, starting point, and at this point what is the value of time t1 say? So Vm sine 100 pi into T1. So this is the maximum value. So we can cancel it. So you get sine 100 pi T1 equals to 1 by root 2. Very interesting question. So from there, what is the 1 by root 2 means? 1 by root 2 means sine pi by 4, that is 45 degrees, right? So from there we can calculate 100 T1 equals to 1 by 4. Okay, pi cancels. So T1 is equal to 1 by 400. So 1 by 400 is the starting point, that is when the value was exactly at RMS value, right? Next we have to calculate, obviously not super easy question, you have to do the mathematics, you have to understand the concept and then you have to solve it, but if you know it how to solve it, this is not super time taking question. So T1 is 1 by 400. Now next part they have said that how long it will take to reach the maximum point. So maximum point is Vm is equal to Vm sine 100 pi t 2. Okay, basically at when it is reaching maximum, the output value should be exactly equals to Vm. So we get sine 100 pi t2 is equals to 1 means sine, obviously 90 degrees, pi by 2. So from here we get 100 t2 pi cancels equals to half, or t2 equals to 1 by 200. Okay, so how much time it will take? Time it will take, delta t is t2 minus t1, that is 1 by 200 minus 1 by 400, that is 1 by 400 seconds. That is if you multiply 25 in top and bottom, you get 25 divided by 4 5 is 100, 10 to the power of 4. So it will be 25 into 10 to the power of minus 4, or 2.5 into 10 to the power of minus 3. Okay, little lengthy question, but still you can solve it. Mathematically not super difficult, concept wise it is little difficult, but you can solve it without using any calculator. So 2.5 into 10 to the power of minus 3 second is the answer for this question. Next question, the readings of ammeter and voltmeter in the following circuits are respectively. So you have to find the readings of ammeter and voltmeter. Another ammeter and voltmeter question. Let's see that VL is given 50 volt. Okay, VC is given 50 volt. So what is the meaning of that? If VL and VC both are 50 volt, then it is the circuit is in resonance. So circuit is in resonance means the value of V should be equals to whatever is the input voltage. So V should be equals to 220 volt. Okay, what is the current? Current is very simple, 220 volt divided by 100, that is 2.2 ampere. So 220 volt, 2.2 ampere. Right? So this is the correct answer. Very simple, without even solving it, without doing lot of mathematics, you can see. So as long as this is a resonance condition, XL and XC are same, VL and VC are same, you can solve such questions easily. Next question. An inductor of inductance L and resistor R are joined together in series and connected by a source of frequency omega. The power dissipated in the circuit is. So inductor of inductance L and resistor R are connected together in series, connected by a source of frequency omega. They asked you what is the power dissipated in the circuit. So voltage is V. What is the power dissipated? How to find the power dissipated in the circuit? So current is I. Okay, so you have to find the current in the circuit, and then you can find the power dissipated as V into I. Okay, so first you have to find the impedance. What is impedance? Impedance is simple, R square plus XL square. Now what is XL? Circuit has a angular frequency omega, so XL must be equals to L omega, right? Put the value over here, so you get Z equals to R square plus L square omega square. This is the value of Z. Now what is the current? Current is V divided by Z. So V divided by Z is V we don't know, Z is square root of R square plus L square omega square. Now what is the current power? Power is V into I or V into V by R square plus L square omega square, or it will be V square divided by R square L square omega square. Okay, V is multiplying twice, so this will be the answer. So it will be V square divided by, now here this option is incorrect, there will be any R over here, so this will be the correct answer. So there are some typo in this question. Anyway, let's move on to the next question. Which of the following represents the variation of inductive reactance XL with the frequency of the voltage source nu? So XL is equals to 2 pi nu into L, right? Generally we use F, but because in the question they have given nu, so XL equals to 2 pi nu into L. So this is a linear relationship, right? No square, no division, no multiplication. This is constant. L for a given value is constant. So definitely XL and nu are straight line relationship. Correct answer is option A. Next question. A 100 watt bulb is connected to an AC source of 220 volt 50 Hz. Then the current flowing through the bulb is. So 100 watt bulb connected to an AC, it is basically, you can consider this to be a normal resistive bulb, and even though there is an AC, you have to find the current flowing through the circuit. Let's see, power is V into I. Okay, power is V into I, that is 100, right? Power of the bulb 100, V is 220 volt. Let's find what is the current in the circuit. So current equals to 100, so I will be equals to 100 divided by 2200, so it will be 5 by 11 ampere. 5 by 11 ampere, this is the correct answer. Now even if they ask you what is the RMS current, okay, this will be the same answer. Why? Because this 220 volt itself is the RMS voltage. So if nothing is mentioned, then the voltage basically represents the RMS voltage. From there you can calculate the current I. Next question. The average power dissipated in AC circuit is 2 watt. If the following through, if a current flowing through a circuit is 2 ampere and impedance is 1 ohm, what is the power factor of the AC circuit? Okay, average power dissipated is 2 watt. Okay, current flowing through the circuit is 2 ampere and impedance is 1 ohm. Okay, what is the power factor of the AC circuit? You have to find the power factor. So power factor is cos phi, which is equals to R divided by Z. So basically you have to find what is the resistance of the circuit. So average power is given. Average power is given means I square into R is equal to 2. Okay, I square is 2 square into R equals to 2. So R is equals to 2 by 4, that is half, right? So R is half, and you have to use the Z value is given over here 1. So it will be half divided by 1. So it will be half. Okay, so this is the cos phi. Cos phi half means it is basically so this is the value. Okay, this is itself is the power factor. Power factor. You don't need to find the value of phi, by the way. And remember that power factor will always be less than equals to 1. So power factor is half, that is 0.5. Don't get confused again. 0.5 option is given, so 0.5 is the answer. In Karnataka, the normal domestic power supply AC is 220 volt 50 Hz. Here 220 volt and 50 Hz refer to RMS value of the voltage and frequency. So correct answer is option B. A step-up transformer operates on a 230 volt line and load current of 2 ampere. The ratio of primary and the secondary windings is 1 into 25, then the current in the primary is. So basically it says that input voltage is 230 volt. Okay, input current we don't know. Okay, input output voltage we have to found, and also the load current is given. Load current is given 2 ampere. Okay, load current means output current. Okay, so this is given 2 ampere. You have to find whatever is the input current, right? This is 2 ampere. Now what is output voltage? Output voltage is number of turns in the secondary divided by number of turns in the primary into voltage in the primary. So number of the ratio is given that primary to secondary is 1:2. So secondary will be 25, primary will be 1, input voltage is 230. Okay, so now you have to put this value over here. So 230 into I equals to 25 into 230 into 2. Obviously I don't want to multiply this huge number, because ultimately 230 will cancel. So we get I, input current I, is equal to 25 into 2, that is 50 ampere. Okay, it will be 50 ampere. Correct answer is option B. The output of a step down transformer is measured to be 48 volt when connected to a 12 watt bulb. The value of the peak current is, okay, obviously it is measured to be 48 volt when connected to a 12 watt bulb. So what is the power? 12 watt bulb means V into I equals to 48. Okay, so that is equals to 12. V is 48, I we are trying to find is equal to 12. So I equals to 12 by 48 equals to 1/4. Okay, so we have calculated the current, but this current is RMS current. Okay, whenever you are using a bulb to measure voltage, measure current, whatever it is always RMS voltage. So IRMS is equals to this. So what is the maximum current? Maximum current is √2 into IRMS. Okay, so it will be √2/4. So √2/4 means 1/2 √2, right? 4 is 2 into 2 multiplied by √2 divided by √2, so it will be 2 √2. Next question. The RMS value of current in a 50 Hz AC circuit is 6 ampere. The average value of AC current in the cycle is. So RMS value, whatever it is, the average value of AC is always 0. Okay, average value of AC is always 0. Okay, RMS is not 0, but average is 0. Next question. A capacitor of capacitance 10 microfarad is connected to an AC source and an AC ammeter. If the source voltage varies as V is equal to 50 √2 sin 100t, the reading of the ammeter will be. So what will be the reading of the ammeter? Reading of the ammeter is very simple. Ammeter will measure IRMS. IRMS is basically VRMS by the resistance. Now what is resistance over here? Resistance is basically 100 microfarad. Okay, it will be because it is only capacitance. Okay, so capacitance means XC. Now first of all, what is VRMS? VRMS is maximum value of the input voltage divided by √2. So maximum value is 50 √2, so it will be 50. Okay, so 50 is the VRMS value. Now what is XC? XC is 1/ωc. Here omega is given. Remember, F is not given, omega is given. Omega t, sin omega t. So omega is 100. So 100 into C is 10 microfarad. So 10 into 10 to the power of -6. Okay, so it will be 10 to the power of 3. That is 1000 ohm. Okay, so what is the IRMS? So IRMS will be 50 divided by 1000, that is 50 milliampere. So 50 milliampere is the correct answer. Not 70.7, not 7.07. Be careful. Don't guess the answer in this kind of questions. Next, in a series LCR circuit, the potential drop across L, C and R respectively are 40 volt, 120 volt and 60 volt. Then the source voltage is. So we know that source voltage is square root of VR square plus VL minus VC whole square. So VR is 60 plus VL is 40 and VC is 120. Now this does not matter because there is a square sign outside. So 40 minus 120 or 120 minus 40 both are same. So you will get we have solved a similar question, 60 square plus 80 square. Okay, so we will take 20 square common from both sides. So it will be 20 into square root of 3 square plus 4 square, which is 5. So it will be 100 volt. Okay, we have solved one question such before, so it will be 100 volt. Okay, just mathematical ability to solve. In a series LCR circuit, an alternating EMF V and current I are given by the equation V is equal to V naught sine omega t, I is equal to I naught sine omega t plus pi by 3. So here to be very careful, it is an LCR circuit, it is not simple L or C circuit. So in case of simple L or C circuit, the average power dissipated is 0, but as soon as resistance is involved, the average power dissipated is not 0. And if you remember, average power dissipated is basically given by VRMS IRMS into cos phi. Okay, that is why cos phi is called power factor. Phi is basically the phase difference, whatever is given in this case. Okay, so VRMS is basically V naught by root 2, IRMS is I naught by root 2, and cos phi is here cos of pi by 3, that is cos 60. Cos 60 means root 3 by 2. It will be V naught I naught by 2 into root 3 by 2, that is the answer is root 3 V naught I naught by 4. So root 3 V naught I naught by 4. I think they have some mistake over here. It should be 4 over here, right? So it will be root 3. If you find any mistake in this problem, pi by 3 is 60 degrees, so cos phi will be cos phi will be half. Sorry, my mistake, I made a mistake. Cos 60 is half, cos sin 60 is 1 root 3 by 2. So it will be V naught I naught by 4. Okay, root 3 will not be there, sorry. So V naught I naught by 4. So the correct answer is option B in this case. Next question, a transformer is used to light 100 watt 110 volt lamp from 220 volt, means if the main current is 0.5 ampere, the efficiency of the transformer is. Okay, so basically what is the power output? Power output is 100 watt. Okay, what is the power input? Power input is 220 volt. Okay, the question seems little confusing, but don't worry. This is the power input. This is the power input, that is 110 watt. Okay, 110 watt is the power input, and the power output is 100 watt. That is why the bulb is operating, right? You are stepping down the voltage to 110 volt, and it is giving you 100 watt power. So what is the efficiency? Efficiency is basically the original power minus the final power divided by the original power, right? This is the formula. So it will be 10 divided by 110 or 1 by 11, okay, into 100%. When you are converting it into percent, you have to multiply it with 100%. sorry, just a second. Because we are only calculating the efficiency, we just need to consider the output divided by input. So output divided by input into 100%. Okay, this is the efficiency. So it will be 1000 divided by 11%, which I think will be very close to 99%. So the efficiency is very close to 99%. Right? Next question. In an LCR circuit at resonance, the impedance is maximum, the current leads the voltage by pi by 2, the current and voltages are in phase, the current is minimum. So in case of LCR circuit, the current is maximum, power dissipated is maximum, okay, impedance is minimum, and the current in the circuit are in phase. The average power dissipated in a pure inductor, is always 0. A multimeter reads the voltage of certain AC source as 100 volt. What is the peak value of the voltage of the AC? So multimeter, any meter always reads the RMS voltage. So maximum value is 100 volt. This is the VRMS. Multimeter reads means it is VRMS. So maximum value is √2 into VRMS. That is 1.41 into 100. That is 141 volt. So it will be 141.4 volt. Next. Oh, okay. We do not have 30 questions in this chapter. I'm sorry for that. 2 questions less. But anyway, I hope you enjoyed this session today, and I'll be back with more top 30 questions from other chapters very soon. Till then, bye.